Right, this is the review sheet for 11.1 to 11.4. Starting up here with 11.4a, so covering a lot of 11.4 and then a little bit of 11.1 and 11.3 on the back. So we're going to list all the factors of 9x squared. Let's start with just 9. We know 1 times 9 can create that, but also 3 times 3. Now we don't need to list 3 twice. It's just the numbers that can be multiplied to create this. Okay, so we could pull that out. And then each one of those also could have an x attached to them. So it could be a 1x, a 9x, and a 3x, but it also could have an x squared. A 1x squared, a 9x squared, and a 3x squared. Now again, each one of those, I could multiply them by something to create 9x squared. That's why they are factors. Okay, number 2, we're going to mentally do this process for both of these, and we're going to find the greatest common factor, meaning one that they share. So starting with the coefficients, it's easier to start with the smaller one because there's just less numbers to deal with, and then try and match one up with the larger number. So 2 only has 2 factors, a 1 and a 2. Now 2 is going to fit into 10. So I know that that's the greatest common factor between these. 10 has 10 and 1 and 5 and 2. But the biggest one that it has in common with 2 is just the 2. And then out of the x squared and the x to the 4th, basically what you do is, we already know that they share an x, and you're going to take the biggest power that you can from both of them. So I can't take 4 from both of them, but I can take 2 from both of them. Okay, so what I've done is I've created something that can be multiplied into both of these. I could multiply this by x squared. If I did that times x squared, I would get 2x to the 4th. Or I could multiply this by 5, and I would get 10x squared. Okay, so I've found the biggest number that both of these can be factored out to. All right, so number 3, now I have 3 numbers, 10, 15, 20. You should see that 5 fits into all of those evenly. So 5 is going to be the greatest common factor for the coefficients. You take a look. First of all, this one has a y and these don't, so I can't factor out a y. Whatever number I'm pulling out has to be able to multiply into all 3 of them. So I cannot factor out a y. I can factor out an x though, because all 3 have x's. This one has 2, this one has 2, this one has 3. So the most I can take at once is 2. All right, number 4. Kind of backwards distributing. 4 times these two things created this. So I did 4 times something and got 12x. So the number was 3, and there had to be an x. 4 times 3x is 12x. And then 4 times this term over here created just a 20. And so that's clearly just a 5. Always you can double check this, distribute, make sure you end up back where you started. So n to the 3rd times something gives me this. Must have a 3, and I need another n. Multiply again just to double check. You end up with 3n to the 4th. Here's the minus, that's already there. And now multiplying n to the 3rd times something to get 5n to the 3rd. So it's got to be a 5. And the n to the 3rd doesn't get any bigger, it stays. So there's no n on this term. Number 6. All that has been factored out is a 3. So 3 times something got me 6y squared. So 2 had to be the coefficient because 3 times 2 is 6. I didn't have any y's, and now I have 2. So that means there must be 2 y's on this term. 3 times 2y squared is 6y squared. Here's the minus, don't need to account for it. 3 times this term got me 12, so that's 4. And now there's a y, so I need a y. And 3 times 7 is going to get me the 21. All right, number 7, 4a squared b multiplied by something got me 4a squared b. Well, that's 1. And now times the second term got me 16, so that's a 4 as the coefficient. The a has increased by 1, so that means I need 1a here. B has also increased by 1, and so I need 1 there. All right, now on 8 and 9, I actually want to jump down. Let's do a couple 10 through 13 first, because the skills we are going to use here is what we're also going to use up here. So we're going to do the same thing we did for 4 through 7, except On that one, they already pulled out the factor, the greatest common factor. So now you've got to do it. So you look at 15 and 35. The factor that's going to come out of that is going to be 5. And so you create the open parentheses. There's two terms with a minus sign here. And now it's just like 4 through 7. So it's one extra step. You had to come up with the greatest common factor like we did on 2 and 3. And then you're going to go ahead and actually factor it out like we did 4 through 7. So 5 times something got me 15x. So that'd be 3x. 5 times something got me 35. And that's 7. Number 11, 24 and 8. The greatest common factor is 8. And both of these terms have an x. The most I can take at once is just 1 because this one has 2, this one has 1. Here's a minus. I'm going to put that there. So 8 times something got me 24x squared. That would be 3x squared. And then 8x times something got me 8x. That would just be 1. All right, number 12. Notice that this can be simplified right now. So before you start trying to factor anything out, you should simplify it. The 20 and the 2, there's no reason for them to be separate. Those can go together. So we're going to leave the negative 6x, but 20 plus 2 is 22. So looking at these two now, negative 6 and 22, they both don't have an x, so I can't take an x. Looking at 6, I could take out a 2 or a 3. 3 isn't going to fit into 22. I could take out a 6, doesn't fit into 22. So 2 is going to be the number. And so to multiply to get a negative 6 would be negative 3x. And to multiply to get a 22, that would be 11. Okay, 13. Taking a look at these, I cannot factor out a number here because this is a 1. So yeah, I could take a 1 out, but that doesn't change anything. So the only thing I can factor out here is the a's. And the most I can take at once is 4 of them. Okay, I can't take out 5 because I don't have 5 to take from this one. So 8 to the 4th is what's getting factored out. So what am I multiplying by to get 18 8 to the 4th? That's just 18. Here's a minus. And to get this, there's going to have to be an x. And the 4 becomes a 5, which means there's also 1a sitting there. All right, let's hop back up and do 8 and 9 before we continue. Okay, just to get you ready for that, we did these. So when I look at number 8, what we're going to do is try and factor the top, just like we did here. And then hopefully what we can do is then out of this, whatever you factored out, we can cancel the bottom. That's what we're trying to do. So because we're in the basics of this section, they've set these up where they will cancel nicely for you. So because of that, you can kind of cheat a little bit and see what you're trying to factor out. So this bottom piece is what we're going to try and factor out. You should double check. Does 48 go into both of those? Well, we probably don't know with a 192, so you should check. 192 divided by 48 is 4. Okay, so that works. And I can take 2 w's out of both. So that's what I'm going to do. I'm going to take a 48 out, and I can take w squared out. So when I now times it times something to get this, that's the same term, so it's just 1. We just said 48 times 4 got me this. Now the w2 became a 7, so this must be w to the 5th. Again, you can always double check yourself. Redistribute it, make sure you're going to get this. And the reason we did that here is because now that we have a product, we can cancel. And my final answer is whatever's left over here, 1 plus 4w to the 5th. Remember, you cannot just cancel when there's addition. The answer is not 192w7. It's 1 plus 4w to the 5th. Okay, so we have to create multiplication to cancel. So here we'd like to factor out this whole bottom piece if we can. Can we take a negative 7 out of both of these? Yes. P to the 3rd? Yes. And just a q? Yes. So we can take all of this out. And create something that will cancel. So let's see, we'd be multiplying. Now, we did take out the negative 7. We did that on purpose, okay, because otherwise we'd be left over with a. If we just took out a positive 7 up here and canceled, that negative would remain, and that can be a little confusing. And so we want to go ahead and pull the negative out now and cancel it completely. So inside here, to create a 21 from a negative 7 would have to be a negative 3. We've got p to the fourth coming from a p to the third, so that means there's just a 1p there. Starting with a q, getting q to the second, that means there's a q. Okay, a negative times something got me a negative, so this must be a positive. And it's a 5. P to the third became p to the sixth, so that's p to the third. And q is just going to stay. So these cancel, and what's remaining is my answer, negative 3pq plus 5p to the third. Okay, down to the bottom, pick up where we left off. Scanning across here, I see numbers that are divisible by 7. I also see there's an x in each one. Most I can take at once from all of them is 2 of them, so x squared. So once I've taken the x squared out of this, all I'm left with is y. Once I've taken 7x squared out of this, 7 times 5 gets me 35, and I need one more x to get it up to x to the third. Put a minus here, it's 7 times 5 again, and I don't need any x's on it because the x squared has not changed. Okay, 15, 42, 30, 24. What number goes into all of those? That'd be 6. Now, this 30 doesn't have any variables, so I cannot pull out a variable here because 30 doesn't have one to give. So it's just a 6 coming out. 6 goes into 42 7 times, and I need all the variables here, so it's b to the fourth. 6 times 5 is 30, and 6 times 4 is the 24, and I need the variables here since they're not here. Okay, 16, 14, 14, and 7. Biggest number that goes into those is 7. They all have a b. They don't all have an a, so I cannot pull out an a. And the most b's I can take is just 1 because this one only has 1. So it's 7 times 2. I've already got the b, so I need to add the a. It's 7 times 2. I've already got 1b, but to create the b squared, I need 1. And it'd be a 1, which I don't have to write. To create the 7 here, b becomes b to the 6th, which means I have 5. And I now have an a. And if you put it in front, you did a, b to the 5th, that's fine. B fifth to the a, same thing. So the order there is not super important. Normally we do alphabetical, but it's not crucial. Okay, 17. 4 can be factored out. And that's it, no variables that they all have. So this is just going to be a squared. 4 times a squared is 4a squared. This is just going to be a b. 4 times b is 4b. And this is just going to be a 2. 4 times 2 is 8. Okay, 18. 32, 48, 40. Think about the numbers that can fit into that. 8 is going to be the largest number that goes into all of them. They all have A's, they all have B's, so we can take those out. Now, if I look at my A's, the most I can take at once is 5. And with my B's, it's 2. Okay, first term is times 4. And the A's increase by 2, and the B's increase by 1. To get to 48, that's times 6. A's stay the same, so there's no A. B's increase by 2. To get to 40, it's times 5. A to the 5th stays, so there's no A on this term. B squared stays, so that is it. This would be your final answer. All right, 19 times 9. You could take a negative 9 technically if you wanted to, but I'm just going to take a positive 9. They don't all have the same letter, so I can't put a letter out here. So it's 9 times negative 4. And since I don't have a variable out here, whatever one shows up here must have been on this term. So x to the 4th, y to the 2nd, times 9, x squared, times 4y. Number 20. Looking at this, at first I thought, 20 must be the number coming out because 20 goes into 100, but it doesn't go evenly into 50. So next, I know 10 times 2, 10 goes here, 10 goes here. So I can take a 10. They all have an x. They all do not have a y, so I cannot pull out a y. And I got to look. The smallest of the exponents is 3, so that's the most I can take at one time. So 10 times 10 is 100. X to the third became x to the fifth. That's x squared. The y comes out of nowhere, so it must have been here. Multiplying into this, that's a 2. X increased from 3 to 4, so it means I had 1 here. So when I multiplied, it went x times x to the third. That's x to the fourth. And the y showed up. And now I'm multiplying times 5 to get to 50. X to the third. I don't need any more here to get there. So this is done. All right, last one on the front. Looking at these, I see that a 6 can fit into all of them. I see a u squared in all of them, so I can factor that out. Don't have a v across the board, so we have to just stick with that. So this would be negative 10 to create 60. Already have the u squared, so here's the v squared. To go to 30, that's times 5. Already got the u squared, so that's v. And then to get to 36, I'm timesing by 6. And again, I've already got the u squared, so I don't have to do anything there.